Hello everyone, I'm Sriram Shankaran, Senior Product Manager at Syncfusion, and I'm thrilled to share how I built an AI-powered sales dashboard from the ground up. The title of my talk, Architecting an AI-powered sales dashboard with .NET MAUI and Azure OpenAI. A full hands-on code-first session where I will show exactly how to build a production-style AI-driven app that runs on Windows, Mac, Android, and iOS, all from a single code base. So let me start with one powerful example. The kind of moment that made me love this project. Imagine you open the app on your Windows laptop and type a simple question in plain English. What are our top performing products? The app doesn't pull up a chart, it thinks. It analyzes your sales records, calculates revenue, profit, and margin, and ranks everything. In seconds, it returns a clean and structured answer like smart TV, this much profit from this much total sales, laptop, this much profit from this much total sales, cloud server, and so on. So this is the kind of summary you can share immediately with your team. And here's the best part. The same app runs on your iPhone, your Android tablet, and your MacBook with zero code changes. It generates AI-powered forecasts with upper and lower bounds for the next 30 days. It summarizes confidence so you can plan with clarity, exports polished reports to PDF, and works online with Azure OpenAI models. So this is not a mock-up. This is real code, real data, real Syncfusion UI, and real AI. And I'm going to show you everything step by step live in the app and in Visual Studio. You will leave this session with a complete blueprint for building AI dashboards, working code you can fork, confidence to integrate Azure OpenAI GPT-5 models, and a repository you can run. So let's get started. First, the agenda. So here's our roadmap for the next 30 minutes. First, overview of the live demo, what you will see end to end, a quick tour of the app's core experiences, then building an AI sales dashboard, decisions that matter, prerequisites for those who will run it later, and then the main section, which is a live demo, hands-on walkthrough where I will navigate each view, change the time period to see charts and KPIs refresh, explore predictions with upper lower bounds and confidence, and ask the assistant for concise data grounded answers. Following that, we will have the architecture deep dive. That is how it all fits together, how the app is structured with .NET MAUI, MVVM for state and behavior, Syncfusion UI components, and Azure OpenAI for assistant responses. And then finally, we will have a look at challenges we solved and practices we kept, that is what worked, the practical lessons, then recap and key takeaways, the blueprint to reuse. With that roadmap in place, let's kick off with the overview of the live demo. So you can see exactly how the app looks and behaves before we dive into the details. So here's what this app is about and what you will see today. So this app is a cross-platform sales analytics dashboard for desktop and mobile, built to give leaders a fast pulse on performance and let analysts dive deeper. You will see at a glance a home dashboard with KPIs, revenue trends, quantity and margin visuals, and a recent sales table, a product view highlighting top products, top regions on a world map, and a detailed product table. Following that, an orders view focused on order status, amounts, and quick exports. Then a predictions view with forecast totals, confidence, time windows, and an interactive forecast chart with upper or lower bounds. Finally, an AI assistant you can ask in plain language for insights and summaries. So with that, let's dive into building an AI sales dashboard, decisions that matter. So what we did was we set out to build one dashboard that could surface live revenue, profit, and trends, answer natural language questions like what's killing our margins, run everywhere, Windows laptops, iPads in the field, and Android phones at trade shows. But what we were doing is we were maintaining three separate apps, same logic, same bugs, three code bases. It was slow and brittle. So we asked, what if we could write it once and ship it everywhere? That's when we chose .NET MAUI. So you can ask why .NET MAUI? There are three reasons. The first one code base, all platforms. We needed desktop and mobile support without fragmenting our team or duplicating features. MAUI let us share view models and services while tailoring layouts for desktop and mobile. Second, native performance and polished UI. With Syncfusion's .NET MAUI controls, we got production-grade charts, data grids, maps, gauges, PDF export, and an AI assist view that feel native and scale well. That cut months of our build time and let us focus on the experience. And finally, first class tooling and integration. Visual Studio, hot reload, and a clean MVVM pattern made iteration fast. Azure OpenAI plugged in cleanly so the assistant and the narrative insights of the prediction page feel like a natural extension of the data, not a bolt on. In short, we chose dotnet MAUI because it let my team ship a cross platform production quality app quickly without compromising on performance or polish. Before we dive into the demo, here's what you will need if you want to run this app later. Number one, Visual Studio 22 with the dotnet MAUI workload. So install the dotnet SDK with the MAUI workload enable. So I'll be targeting Windows for today's demo, but you can switch to Android or iOS with the same code base. Number two, a Syncfusion license. You have three options: a commercial license, a free community license for eligible developers or small teams, or a 30-day free trial. You can sign up, verify your email, and obtain a license to activate the controls. Number three, required NuGet packages. You would need a Syncfusion dotnet MAUI packages for the UI: charts, data grid, gauges, maps, buttons, PDF, and the AI Assist view, and so on. And an Azure OpenAI client package to call Azure hosted models securely. If you would like the exact package IDs and versions, you can check the project's package reference in the csproj file when you pull the source. And you would require an Azure OpenAI account where you can sign into the Azure portal, create an OpenAI resource, deploy a chat-capable model, and grab your endpoint and API. With the prerequisites covered, so let's jump straight into the live demo. So as the app opens, you land on the main dashboard, as you can see on the screen. On desktop, you can see a left navigation with sections named Home, Products, Orders, and Predictions. On mobile, the same sections appear as tabs at the bottom. There's also a floating or dock button to open the assistant panel. So let's begin with the home dashboard. At the top, you can see a row of quick KPI cards: overall revenue, profit, margin, and growth. So these cards reflect the currently selected time period and update instantly when we change that period. Below, we have a revenue trend chart that visualizes performance over time. You can notice the time period picker over here. When I change the period, for example, from last year to last 30 days, the entire dashboard refreshes. I'll just show it to you now. Yeah, the trend line recalculates, the KPIs update, and the rest of the visuals reflect the new window. To the side, you will see a quantity sold chart. Its numeric axis is formatted to keep values readable, that is, thousands, millions, or billions are abbreviated automatically. Next to that is a profit margin chart. The date labels are optimized, as you can see. The start of a new month is prominently formatted to orient you at a glance. And finally, there's a data grid at the bottom listing the most recent sales entries: product, region, quantity, revenue, and cost. So you can dive into rows while scanning the charts above. Support for paging has also been added to this grid. So next, let's move to the products page. Moving to the products page, we start with a top products donut chart. It highlights your top performers and places their values right on the visual for quick comparison. On the right is top regions, a world map with markers for your key markets. Each marker gives a geographic view of concentration and reach. Below, there's a detailed product list, which includes inline information like product rating and stock status, along with totals and sales metrics. There's also a one-click export to PDF action that generates a polished report of the grid you're seeing, which should be great for sharing with the team or embedding in a slide. Okay, we will move to the orders section. In the orders section, you will find a streamlined grid that focuses on order level details: customer date, status, and amounts. Status badges are color coded to quickly show delivered, shipped, refunded, or cancelled orders, as you can see on screen. Just like the product list, this view includes an export to PDF action, so you can easily capture and distribute the current table. Okay, now let's look at predictions. This is where the app blends analytics with AI. At the top, you will see three key tiles. First one is the performance revenue, showing the forecasted total for the selected period. Then the prediction period, clearly marking the start and end dates in plain language. Following which you have average confidence, a radial gauge showing the model average confidence for the forecast. Below that, you will find a detailed chart with three lines: the central forecast curve, a lower bound, and an upper bound. So these bounds visually communicate uncertainty, so you can plan conservatively or aggressively depending on your risk tolerance. There's a control that lets you switch between the chart and a tabular view of the same prediction data. When predictions load, you will see a clean busy indicator, so you know something's happening without blocking your flow. At the bottom is an AI Insights panel. So this is a narrative explanation that summarizes what's driving the forecast, useful for executive summaries or stakeholders who prefer narrative context with the numbers. So now let's open the assistant. This is a conversational panel where you can ask questions like which products contributed most to profit last quarter. So when you ask a question, the app builds a context-aware prompt using the latest sales summary and returns a concise text response. The output is cleaned up for readability and presented as a chat response. You can use the suggested prompts to get started or simply type your own natural language query. So what I will do now is I will click on the suggested prompt, which queries the top performing products. There you go. We have the requested output from AI. So let's have a look at it. Smart TV is the winner over here. On mobile, the experience mirrors what we just saw, but optimized for smaller screens. So to recap, this app brings together multi-view analytics across home, products, orders, and predictions. Each page blends at a glance tiles with drill down tables. The assistant helps you query and narrate the analytics conversationally, while forecast provides both numbers and confidence. Whether you're on desktop or mobile, the experience is cohesive, quick to navigate, and ready to share via PDF exports or AI generated summaries. So that wraps the live demo. As promised in the roadmap, the next step is connecting the experience to its internals. .NET MAUI for the cross-platform shell, MVVM for state, services for data and AI, and how they compose the views we just used. So let's jump into the architecture deep dive. For that, let me open the app in Visual Studio. So this is a cross-platform .NET MAUI application that targets mobile and desktop. It uses MVVM for structure, Syncfusion for rich UI controls like charts and grids, and Azure OpenAI to power an in-app assistant and predictive insights. I will guide you through the startup flow, the folder structure, the platform-specific compositions, and the core interactions while referencing the actual files in the repo. So let's start with how the app boots and chooses the right UI for each platform. For that, I will now open mauiprogram.cs file. So this class builds the MAUI app, registers the Syncfusion license, configures Syncfusion core, sets up fonts, and enables debug logging. So here's the key part. Next, I will open mainpage.xaml.cs. So this is where the app decides which composition to load based on platform. It shows a splash, delays briefly, then swaps the content. On Android and iOS, it loads Android UI. On Windows and Mac Catalyst, it loads desktop UI. You will also see the app shell.xaml, which defines a shell class, but in this code, the app is actually driven by setting content directly in main page instead of navigating via shell routes. Now let's have a look at the architecture layers and responsibilities. So let's talk about the main layers: models, view models, services, and views. Under model data model.cs, you will see the domain classes. So let me just open it and navigate to the sales data class. So this is the most important class, which includes computed properties used all over the UI. You can also notice how profit margin, and profit percent are calculated on the fly, which keeps the view model simpler. For predictions, what we will do is we will take a look at sales prediction in the same file. So it includes predicted revenue, upper bound, lower bound, and confidence, which feed charts and KPIs. View models are under view model folder. So I will just open the base view model.cs file. So this gives us shared UI state like is busy and a selected date range that defaults to the last 30 days along with iNotify property changed. Following that would be the sales trends view model. So this loads products and regions, builds map markers, retrieves sales data according to selected date range, and computes KPIs for the dashboard. So it also handles pagination for grid items. For example, what I will do is I'll just navigate to a method named initialize. So what this method does is that it loads products and regions and sets up markers for the map. So next to the prediction view model. So this orchestrates predictions using prediction service. So for that, I'll just navigate to the generate predictions method. So this method, what it does is that it computes the average confidence and total predicted revenue. It prepares chart data, paginates results, and fetches a narrative insight using Azure OpenAI. Services, they live under the service folder, where the sales data service produces and serves data and summaries. Prediction service, it bridges sales data service with Azure base service, and Azure base service wraps Azure OpenAI usage. So let me just open prediction service. So here's how the prediction service calls into the AI layer, as you can see in this particular method, and how we ask for a narrative explanation. So next is the Azure base service. I'll just navigate to the methods section now. So the methods I'm like showing now, what they do is they do the client creation, credential validation, and completion call. So now let's see how we compose the UI differently for desktop and mobile. On desktop, what I will do is I will open desktop UI.xaml file. That's under system views. So as you can see over here, it uses a navigation drawer for the side menu. And has a right hand AI assist panel using SF AI assist view that I'm like highlighting over here. The main content view is where we inject the page content. Next, we will have a look at the desktop UI.xaml.cs file. I'll just open it. So this constructor is the composition root. It builds the services, the two view models, wires up the pages, and sets the initial content. It also handles page switching and the AI assist request pipeline. For that, I'll just navigate to the AI assist view request method. So over here, when a user submits a question in the assistant, it builds a domain-aware prompt from current sales data, calls Azure OpenAI, cleans the response, and adds it to the messages collection bound to SF AI Assist view. On mobile, the composition is similar, but uses a bottom tab view. So this can be seen in the Android UI.xaml file under mobile views. So each tab hosts a dedicated content view like Home Android or Prediction Android, which themselves they compose reusable custom views such as charts, grids, and metric cards. So following that, let's discuss core user flows and why they matter. First, period-driven dashboard refresh. For that, what I will do is I'll just open revenue trend chart.xaml.cs file. So when the user changes the period in the combo box, we update the selected date range on sales trends view model and reload both the data sets and summary KPIs. So this event is the heart of the dashboard refresh. Second, export to PDF. So what happens with export to PDF is that it is a signature feature showing reporting capabilities. So it's like available in multiple files, namely the product list and order list. So first one is the product list and order list. So maybe I'll just open the order list xaml.cs file. So this export as PDF handler uses Syncfusion's data grid PDF exporting controller to render the current grid view to a PDF and then saves it via a save service. Third, predictions and insights. Prediction view model, what it does is that it pulls predictions, computes visual series, and requests a narrative insight that is shown in the all insight details.xaml file. So I'll just open it via the insights explanation binding that you can see on screen. Next, I'll open the predictions details.xaml file. So this view, it shows 3 line series, as you can see over here: lower bound, upper bound, and predicted revenue. And the fourth core item is polished chart labeling, which enhances readability. For that, I will open quantity chart xaml.cs file. If you just have a look at here, the numeric y-axis labels are formatted into K, M, and B. Similarly, in profit margin chart xaml.cs file, the date labels have been formatted. So I'll just open it. So here, the date labels have been formatted to highlight month boundaries. Now coming to Syncfusion components, they are used throughout the app. They are initialized in the MAUI program.cs file as discussed already. And here's how they show up in the UI. For example, let's start with charts. So I'll just, okay. So charts are available in revenue trend chart.xaml file, quantity chart, profit margin chart, and product chart.xaml file. So I'll just open one particular file and show you the chart implementation over here. So there you go. So data grid with PDF exporting is used in order list and product list. So this is order list file and the product list file, and glue to exporting into XAML.cs files with Syncfusion MAUI data grid exporting and Syncfusion PDF. So let's have a look at the data grid implementation. Coming to gauges, they are available in the average confidence.xaml file, which shows a radial gauge for average confidence. Maps are used in product sales region XAML file for world map markers generated from the view model. Following that, buttons, tab views, and inputs are all used across the application, and the AI Assist view, which is Syncfusion MAUI AI Assist view, is embedded in both desktop UI XAML and Android UI XAML for the assistant panel, as we already saw. So let me just, make changes to the folder, that is collapse them now, in order to summarize this exact flow. So to summarize the flow, at startup, the app selects the appropriate UI shell for the current device. So that shell composes the core services, data access, AR interference, and orchestration, then instantiates the primary view models for the dashboard and predictions. The screens bind directly to these view models, so state, data, and interactions flow through a single consistent MVVM pipeline, regardless of platform. The app is a clean example of MVVM with a strong separation of concerns. So what we will do is, we will just start with the models. So the models encapsulate business data. View models orchestrate loading and transformations. Followed by that, services, they bridge data and AI. Custom views provide reusable visual components. And mobile views or system views compose the screens per platform. And Syncfusion provides the rich UI building blocks, and Azure OpenAI adds conversational and explanatory AI on top of the analytics. That's the architecture under the hood. So let's switch gears from here on how it's built to what we learned, the practical fixes and best practices that kept this app fast, readable, and reliable across devices. So now I'll just summarize the practical lessons from building this app, what broke, how we fixed it, and the practices we kept because they consistently work. So first challenge, we needed a single code base to feel native on desktop and mobile without forking features. So what worked was build small reusable views, that is charts, grids, metric tiles, maps in custom views, and compose them differently per form factor. So the same views appear inside desktop pages and mobile pages. The platform switch happens after the splash. The second challenge, when the user changes the period, every KPI, chart, and grid should update smoothly. So we handle selection in the header and push state through the view model. In, for example, revenue trend chart, we set selected date range and then initialize and load summaries. We bind busy state and show indicators on prediction screens. So the result was that data refreshes without UI hitching. The next challenge, time and large numbers get noisy, especially on mobile. For that, we formatted access labels in code behind. For example, the profit margin chart and quantity chart, they adjust datetime labels and scale numbers to K, M, or B. Small polish, but big readability win. Okay, so as we wrap up the section on challenges we solved and practices we kept, let's bring the whole story home. You have seen how a single dotnet MAUI code base can deliver a polished sales dashboard across devices. So what's next? Pull the source, run the app on your platform of choice, and explore the home, products, orders, and prediction screens. Plug in your Azure OpenAI deployment and your data. Reuse the patterns, which are shared view models, reusable views, and consistent export flows to ship your own cross-platform AI-assisted solutions. I hope this gave you a clear blueprint and the confidence to build your own AI-powered dashboards with dotnet MAUI. With that, we have come to the end of the session. Thank you all for joining.